Gravity, the force that draws everything towards one another. The formulation of the theory of gravity was brought forward by scientist, alchemist, Kabbalist, and philosopher Isaac Newton. Sir Isaac Newton, as Wikipedia states, is widely recognized as one of the most influential scientists of all time and is a key figure in the scientific revolution. His book Principia Mathematica, or The Mathematical Principles of Natural Philosophy, first published in 1687, laid the foundation for classical mechanics. The gravitational constant itself was not calculated or determined until the late 19th century, done so by a scientist named Henry Cavendish. I'm going to let this university professor give you a quick background into the history of Mr. Henry Cavendish and his experiment to find the gravitational constant, or Big G.
One of my favourite scientists is Henry Cavendish. Even though he was part of the rich dukes of Devonshire, that family, and incredibly rich, he went to Cambridge to study natural sciences, or natural philosophy as it's called. But he had a very curious condition in that he could hardly talk to anybody. So when it came to his Viva exam after 3 years of study, he fled Cambridge rather than sit in front of the examiners because he was petrified of them. This is not the normal sort of person. He couldn't talk to most people. He couldn't talk to women at all. His housekeeper would get a recipe for something or other, and he'd say, no, lamb tonight, leg of lamb, and leave a note for her. He wouldn't say it, he'd write it. He would dine in the evening with his friends, and he would talk to them, but if he didn't know somebody, and you wanted to ask him a question, apparently you had to go to the Royal Society, and he would be in the room, and you'd address the room this question about physics, and you postulate, and if he felt in the mood, he would reply to the room. He was a very strange man. He did most of the experiments quietly on his own, keeping his notebooks, and it was only after his death and a persuasive campaign by Clerk Maxwell, the famous Maxwell of Maxwell's equations from Cambridge University, that he actually got the notebooks from the estate of the Dukes of Devonshire and discovered after the event that Cavendish had discovered the unit of capacitance, discovered dielectric constants, he discovered Dalton's law of partial pressures, he discovered or written about Coulomb's law, all before these guys had done it and just left it unpublished in his notebooks. Towards the end of his life, he did a crucial experiment, which is represented by these lead balls. He lived in Clapham Common, which is nowadays a very poor part of London, but there it was quite fashionable. And he built his own place. His library he built somewhere else because he didn't want anybody borrowing his books from his house. Otherwise, he would have to ask the book back and he didn't want to talk to them. So his library was 4 miles away. At the back of it, he had a big garden shed, which might seem like the size of my house. And in it, he had 2 lead balls, like this, suspended from the ceiling. Only this is not to scale. This is, lead balls. Now, the real problem is that he wanted to measure the attraction between 2 objects due to gravity. In other words, there's a gravitational attraction between you and me, or between me and this lead ball. So he had to be a long way away to look at the experiment, otherwise he'd interfere with it. So he had an aperture, a place where he could look through, and he put a telescope out there, and he stood outside in all weathers, and he was in his 60s doing this, staring through the window to take his measurements over a year. There's another set of lead balls inside there. This experiment really is very difficult to get to work, and a technician has sawed it apart because he got so frustrated. And then right in the middle there's a bit of glass, there's a mirror which should be suspended from a torsion wire. So you'd set it up like this in his shed, and you put it like that, and this lead ball would attract that lead ball, and this lead ball would attract this one, and so it would be pushed a little bit this way and twist the wire, and that would be pushed a little bit that way, and the wire would twist, and as the wire twists, the mirror, which is dangling in there, would twist a little bit, and light which comes in would be reflected off at a slightly different angle, and all he had to do was measure the angle. He then had to move it the other way round. Oh, he didn't move this bit, he moved the lead balls round so that you had an equal and opposite effect on the other side. So instead of you'd have that configuration. He had this is a very complicated technical thing for the time. 18th century we're talking about, and he put that that way round, and then it was pushed the other way, and you could then see the displacement. Moreover, you could measure the period of oscillation of this, and from that get all the properties of the wire, the torsional constant. And that enabled him to measure big G, the gravitational constant, to an accuracy of 1%. And nobody improved on that for 100 years. He didn't describe it as that. He described it as though he was weighing the Earth. He was calculating the mass of the Earth, so that when you're attracted to the Earth through gravity, it's the product of the mass of the Earth, this big gravitational constant, divided by r squared, the radius of the Earth squared, which we normally know as an acceleration due to gravity. And that quantity is essentially big G, and he measured it.
Wikipedia tells us that the Cavendish experiment was the first experiment to measure the force of gravity between masses in the laboratory, and the first to yield accurate values for the gravitational constant. This experiment, and the constant derived from it, has laid the foundation for all the current science and theoretical physics dominating the intellectual landscape of today. The entirety of modern physics, in essence, is anchored, one way or another, on the gravitational constant. Big G is used to measure the weight of galaxies and planetary bodies. It is even used theoretically to calculate the very instance of the birth of the universe. In fact, CERN, or the Large Hadron Collider, is a multi-billion-dollar particle accelerator built underground on the border of Switzerland and France that is said to simulate the conditions at the moment of the Big Bang, which is the currently accepted cosmological creation story dominating the minds of modern physicists. It is quite remarkable that all of modern physics is based on an experiment that is not continually being tested and retested to authenticate its veracity. Should there not be a continual Cavendish experiment being conducted to make absolutely sure that this experiment is concrete enough to establish such a fundamental in physics? If investors and governments are willing to spend billions and billions of dollars on CERN, why doesn't modern physics demand such money and focus go to verify one of its fundamental laws? I'm going to leave you with this very illuminating quote about the Cavendish experiment, and this comes from a gentleman named Miles Mathis at milesmathis.com. The Cavendish experiment is routinely included in a short list of the greatest or most elegant experiments ever done. Like all of the other existing dogma, it has surrounded itself with a nearly impenetrable slag heap of boasting and idolatry, most, if not all of, sloppy and unanalyzed. This was true even before the internet arose, but now it is true to the nth degree. Like everything else, the Cavendish experiment has added to its armor 1,000 Wikipedia-like entries and glosses by 1,000 mid-level physics professors. Of the many thousand recent reruns of the experiment, not one appears to have begun with any level of skepticism. Not one is actually set up to test or extend the experiment. Not one starts with the assumption that Cavendish might have been wrong. Despite the stated sacred nature of the scientific method, actually having an open mind about any standard model theory now appears to be equivalent to heresy or sacrilege. Number 9.